Hey there, I'm Jakub and I'm the founder of the project Picoballoon. The project Picoballoon started as a small project of mine in Slovakia, but over time it developed into a large international research effort, where a team of students from all over the world work on the development of technologies and methods to research weather behavior. We accomplish this thanks to our ultralight probes, which can fly for very long periods of time and collect atmospheric data. In this video, we will take you through the whole life cycle of our probes, starting with the design and ending with the launch and data analysis.
Each probe starts at the design stage. There are many parameters a probe needs to fulfill. The ultralight components help us ensure more stable and long-lasting flight. Our current probe prototype weighs around 5 grams with all its mechanical and electrical systems. Along with this, they need to be of low cost and easy to manufacture.
In our labs, we use high-end tools for assembly and testing of our probes. Since many of our components use sub-millimeter pitch, and others are smaller than a millimeter by themselves, we need to be very precise during this process. We do most of our work under our microscope. After placing all the components on the printed circuit board, we place it into our soldering oven, where the components get soldered to the board.
During the flight, our probes are exposed to extreme conditions, such as temperatures of -50°C, relative humidity ranging from 0 to 100%, and mechanical loads caused by the balloon moving in the atmosphere at speeds reaching 200 km/h. Despite these extreme conditions, we try our best to realistically emulate these conditions here on the ground. We also rigorously test the power systems to maximize the power source capabilities and minimize the power load.
Our team not only develops the probe hardware, we also design and manufacture the balloons themselves. But the probe is of no use if the balloon isn't inflated and calibrated properly. This is exactly why we developed our own physics simulation software, which helps us predict the adequate pressure and flight path for the balloon. After the balloon is filled with helium, it's completely sealed off so it doesn't leak during the flight. When planning the launch, we consider many aspects. We scan the neighboring obstacles to prevent any issues, and we also monitor weather so everything can transpire as smoothly as possible.
If everything goes according to our checklist, we can finally launch the balloon. The ascent of our balloons is very slow, reaching an altitude of 10 kilometers can take even 2 hours. Our balloons float at this altitude for several days or even weeks, while the newest models should stay afloat for months. During this time, they can collect heaps of data related to weather, light spectrum, gas concentration, or the location and movement of the probe. The data is then being transmitted to us over the LoRaWAN network. Consequently, this data gets sent over and processed at our server. This allows us to easily check and analyze this data on our web dashboard in real time.
As you have seen, designing, manufacturing, testing and launching of our balloons takes a lot of effort. The technology and its implications go far beyond the student project. We won't stop improving our technology and exceeding our expectations.
Our team is much larger than just the people you have seen in this video. We value all of our team members and try to make everyone learn new skills along the way. If you are interested in joining us, whether as a new team member or as a project partner, or if you simply want to learn more about the project, feel free to check out our website to find out more.